Hi guys, good evening all. I'll be starting the session now. Good evening, sir. Please start session. Right. So today's topic will be NLM, Newton's laws of motion, friction, and work power energy. Right. So I'll just give an intro of the sessions. I hope you guys can see the screen, right? Just a minute, chat. No, you cannot. Just present, share content, screen. Can you see it now? No. I hope you can see it now. Yes, wonderful. Done. Yeah. So NLM, Newton's laws of motion. I'll just give a small intro. So you know all the three laws. So mostly we'll be using the first one and all three obviously. The first one, force is kind of a body continues to be state of rest or this one, right? So here, what does it mean? So F is equal to rate of change of momentum, that is dP by dt. Force is nothing but rate of change of momentum, dP bar by dt. So momentum is nothing but mass into velocity vector. Mass is a scalar value, V bar is the velocity vector. Now, in general, most of the questions mass is constant, but there are questions where mass is not constant, like a conveyor belt on which sand is falling or a rocket. So these type of questions, mass is in reality for any system, mass is not constant. But conceptually, we assume mass is constant and solve the questions. So momentum is mass into velocity. So force is equal to d by dt of mass into velocity. So if you remember UV rule, it is m into dv bar by dt plus v into dm bar by dt. So here for a constant, not dm bar, it is just dm, v bar. For a constant mass system, when mass is constant, this part becomes zero. That is like a car moving or a block being pushed and all. So there we say F is MA. If you remember, F bar is MA bar. But it is not always right because we have this extra term. So please do understand that. And LLM, we have free body diagrams. Free body diagram means if there is a block hanging, so we'll write tension. Tension will be acting at this point, and at the center, mg will act. If tension is more, it will go up. If mg is more, it will go down, right? So be clear about that. And if it's on a surface, if a block is kept on a surface, at this surface we have normal force. From the center we have mg, and at the interaction surface between the block and the surface we have frictional force F. If you are trying to push it with some F dash, external force. These are the few basic concepts. So based on this, we'll be going in depth. So easy one. A body is accelerated by a force, applying a force of 30 newtons. The change in momentum of the body after 2 seconds. So there is a body, some random body. He didn't give any mass. He said there is a force F, which is 30 newtons. The change in momentum after 2 seconds. So only two things are given. This is 2 seconds, time and force. So as you know, dP by dt is force. So dP is fdt. You can remember why I'm writing this. This is always valid. When force is a function of time, momentum is a function of time, still this is valid, right? If you integrate, delta P is integral f dt. This integration. If f is constant, if f is constant, then we get delta P is f comes out of the integral dt, which is f delta t. So in this question, force is constant, it comes out of the integral. So f delta t, f is 30, delta t is 260 kg meter per second. Also be clear about the units, guys. This is the first one. If you have any questions, I guess you can post that in the chat bar. Once in a while, keep checking that. Or at the end of the session, we can discuss. Next one. Two blocks of mass 2 kg and 5 kg. 2 kg and 5 kg are connected by a light string passing over a frictionless pulley. So is a frictionless pulley. So people, they say frictionless pulley. What is the meaning of it? Frictionless pulley. So when there is a pulley, it is taut. There is a wire tension T1. There is another wire tension T2. If it is frictionless, T1 is equal to T2. If it is frictionless, T1 is equal to T2. If it got friction, if we have friction, if that rope and the pulley are rough surfaces, then pulley starts rotating. That means if pulley is rotating this way, then if it is T1, T2, T1 greater than T2. If pulley is rotating this way, then T2 greater than T1. This happens for rough pulley. Is that clear? So this is a little idea. Again, so frictionless pulley, the tension in the cord connecting the masses. So one is how much? 2 kg, other one is 5 kg. So which one will go down? So obviously 5 will go down, with acceleration A. If 5 goes down with A, if this rope goes down with A, this will go up with A. What is the weight of this? 5g. What is the weight of this? 2g. So how to solve this? I can just redraw the diagram as this way: 2 kg, 5 kg. Assume this is going right. So this is also going right. This way 5g, this way 2g. Now the net will be rightward, no? So what is the net force? 5g minus 2g is equal to, what is the mass? Total mass. Both are having the same acceleration. 5 plus 2, 7a. So acceleration is equal to 3g by 7. Acceleration is equal to 3g by 7. So another formula for this is m2 minus m1 by m2 plus m1 into g. This is called Atwood machine, simple Atwood machine. I hope you know this. So this is the formula. Now how to find the tension? Now you know, take either of the block, either 5 kg or 2 kg. So let the tension here be T and T. If I take 5 kg block, so it is going down. That means 5g is more than T. 5g is more than T. That is why it is going down, right? So 5g minus T is 5a. From this, tension is equal to, tension goes right side, this comes left side, 5g minus 5a, right? So T is equal to 5 into g minus 3g by 7. So it is 5 into 4g by 7. 20g by 7. Is it right? 5 plus 2, 7. Yeah. So 200 by 7. What is the answer we are getting? Tension in the cords connecting the masses. 7. Yeah. 3. 3. 3, 4. 20. Yeah. So other one, another way, you can take 2 kg block. If you take 2 kg block, now I have to write T minus 2g because the block is going up. That means tension is more than 2g. So in this case, T minus 2g is equal to 2a, or T is equal to 2 into g plus a. So again, g is how much? G is same. A is 3g by 7, right? 7 plus 3, 10. 10 to again 20g by 7. Is it clear, guys? 7 3s are approximately 30, right? Approximately 30. So 7 3s are 21, right? Or 28. It is a little less than 30, so 28, I guess. G is 9.8, so it is less than 21. So it is again smaller than 3. So I get 28, I guess. Yeah, among the available options. So frictionless, I told you what is the use of it. Then I told you how to solve it, taking 2 different blocks. Next one, a bob hanging from the ceiling of a car acts as an accelerometer. So there is a bob. So what is the meaning of it? If the cart, this is the complete cart, okay, it is hanging. If the cart goes with A, there is a pseudo force MA. And because of weight, mg. So if you are inside the cart, if this is you and inside the cart, you can see the bob goes backside, right? So, sorry. Yeah, just let me check any charts. This is 9.8, 28. Right. Shravya, Harshil, right. Just a second. Why this is coming up? Yeah. So here when it goes with an acceleration, there is a pseudo force. So I'll draw a free body diagram. Because of MA, what happens? We'll come to equilibrium somewhere here. This is MA, this is mg. With the vertical, this angle is theta. So if you extend this, these are two parallel lines, transverse, this will also be theta, right? So if you equate, basically there are two ways. In this direction, it is under equilibrium. This is mg sine theta. This is ma cos theta. So mg sine theta is equal to ma cos theta. So theta made by Bob with the vertical, this should be very clear. If theta is with the horizontal, answer will be different. M gets cancelled. Tan theta is equal to a by g. Tan theta is equal to how much? A by g. Or a is equal to g tan theta. So same question, I just thought kind of another one, the another way they will ask you is, a vessel containing water moves with constant acceleration towards the right. So there is a vessel, there is a water, some water inside, then acceleration A. It's going towards right, that is important one. Which of the following figures ABC represent the surface? So you can just imagine you running with water. So water will try this backside, it will be more, and front it will be less. So it will become like, if you are much faster, so this will keep on increasing and water will spill out, right? So as you are increasing, this angle is theta. It is same as this theta. So these two thetas are same. So here also if they ask you what is theta, tan theta is equal to A by G. But here it is with the vertical, here it is with the horizontal. So very clear about that. If A is 0, theta is 0. In this case, if A is 0, theta is 0. Here also A is 0, theta is 0. That is how we should cross check whether what we did is right or wrong. Clear? Hope you understood this. So using the same concept, there's a question, application of that. A tank with base length capital L is filled with a liquid to height capital H. Then tank is accelerated horizontally. Same question with an as shown. A small hole is made at A. There is a hole at A. Then it is observed that liquid does not come out of the tank. Then what is the value of A? So if it should not come, what will happen? So liquid level, so whatever this H, right, this is also H. So liquid should be something like this. Agreed? So then water won't come, no. So acceleration should be such that, this liquid, whatever here, it will move here. You understood? It is like you have removed it and placed it there. So this is H. So when this triangle comes, this is H. So tan theta, what is tan theta? Same formula, A by G. And from the triangle, what is tan theta? 2H by L. Tan theta opposite by adjacent, opposite is H plus H 2H by L. So the value of A is equal to 2GH by L. Right? But what is the logic here? The water should not come out of A. That means water should still reach here. It should reach the lowest point. That is the logic here. Right? So using that, we have solved this. Fifth one, the block A and B of mass 4 kg and 12 kg are placed on a smooth horizontal plane. The force, this is 4 kg guys, this is 12 kg. F is equal to 16 Newton as shown. Then the contact force between the blocks. It didn't say anything about friction. That means mu here is 0. It is frictionless surface. Now, they have to move together. If I say iska acceleration A1 and this got A2. So what can you say? If they have to be in contact, your friend is pushing you from behind. So in that case, acceleration should be same. So both got same acceleration. A. Net force is 16 Newton. And what is the total mass? 4 plus 12, 16 into acceleration A. So A is equal to 1 meter per second square. This is the common acceleration. If I ask you to draw the free body diagram, then see this block, 4 kg, there is force F, which is 16 Newton. Imagine there is a normal force, contact force, N this way. So action reaction pairs. If there is N here, I have 12 kg here. There will be N here. Action, reaction. Also, we have weight of this 4G and another N1 here. Also here, weight of this 12G, another N2. But they are useless as of now. For this question, horizontal motion, these two are useless. This becomes useful if you have friction. Then this N1, N2 does matter. But so N1 is equal to 4G here, N2 is equal to 12G. I'm just giving you overall idea. Now friction in this case is zero. They're asking you what is the normal force. Again, either take this block or this block. I'm taking the second block. So N is equal to 12 into acceleration. So 12 newtons. Similarly, if you take this block, 16 minus N is 4 into acceleration. So N is equal to 16 minus 4 into acceleration is 112 Newton. So both cases we got the same N. So 12 Newton is the answer. Right? Let me see. In between, I'm just toggling so that I want to see. Zoom audio, na? Right. Next one. Are you getting D? I guess C. Yeah. N bullets, each of mass M, are fired with a velocity V. See, I'm just trying to change the level slowly. We still got so much level. Not even this. I'm trying to send you assignment and collection of previous AIMS, IIT mains question, which was AEEE long time back. I got a soft copy of this one edition. I'll try to send you that, share you through your admin. So they try to solve those questions. They got collection chapter wise. So solve those questions. N bullets each of mass M are fired with a velocity V at the rate of N bullets per second. So there are total of capital N. Each of mass M are fired with a velocity V. Each one's velocity is V, mass M, with N bullets per second upon a wall. The bullets are stopped by the wall. So there is a wall. So there is an Iron Man, someone here. He got total of N bullets. Here he is firing N bullets per second. He got N bullets per second. The bullets are stopped by the wall. The reaction offered by the wall to the bullets. So reaction, again, the force when the bullets hit it, right? So what is the force? So at the bottom, it will stop it, right? So force is equal to dP by dt. So your mass of each bullet is fixed, but there are number of bullets. So it is N times mv per second. Per second, how much momentum is being transferred? N times small mv. So N is the number of bullets per second, capital M into V. So it doesn't depend on capital N. Because if Iron Man got 100 bullets, he's shooting you 1 bullet per second, right? In another case, Iron Man got 10 bullets, but he's shooting 5 bullets per second. So it is not the number of bullets with Iron Man which matters to us. It is number of bullets which are hitting you matters. That's what matters for us. So N times small mv. A rocket set for vertical launching has a mass of 50 kg. So there is a rocket whose mass is how much? 50 kg. And it contains fuel of 450 kg. Fuel is how much? 450. It can have a maximum exhaust speed. Whatever exhaust comes, the speed is 2 km per second, which is 2000 meters per second. Conversion of units. G is 10. What should be the minimum rate of fuel? Rate of fuel means the rate at which the fuel is going out, dm by dt. It is rate. Rate means how much it is changing or how much is going out. To just lift it, right? So there is no acceleration. You just need to lift it. Sorry, guys. Yeah. Chat. What is that? Sixth question. Okay. I cannot go back again and again. We have a lot to do, but anyway. So sixth question. You can take a screenshot once. So if you want to remember, till you get the notes, you can actually keep taking screenshots of each question. So after the once the question is done, take screenshot and try to solve it on your own. It will be more helpful for you. Agreed? Done? Okay. Seventh one. Or at the end, if you want, I can again show you, sheet by sheet. So here, the acceleration is 0 because just lift. So who's giving the upward thrust? Which upward thrust is equal to velocity into dm by dt, because velocity is constant he gave. This force should be equal to weight mg. If force is equal to mg, then what happens? It just lifts off. So velocity is how much? 2000. I'm writing here. So equation is here. Velocity is 2000 into dm by dt is the question here, is equal to mass. So mass is 50 plus 450. Don't just write 450 or 50. Add it. 500 kgs, units are fine. And G is given as 10. So into 10. So dm by dt is 5000 by 2000. So how much is it? 2.5 kg per second. Hope you understood this, guys. 2.5 kg per second. Next one. A block can slide on a smooth inclined plane of inclination theta kept on a floor of a lift. There is a lift. There is an inclined plane. A block is kept on it. I'm just assuming mass m. This angle is theta. And the lift is descending with a retardation. Here is the crux, guys. Lift is descending. That means it is going down with velocity v. That is the meaning. Lift is descending means lift is going down with velocity v with retardation a. So downward minus a. Retardation means downward minus a, or I can say upward a. This is the logic here, guys. It is descending, going down with velocity v. Retardation a. So instead of them saying the lift is going up with an acceleration a, they said this descending. It's like just when you are going from 5th floor to ground floor. So while reaching the ground floor, it is coming to rest. That is when the lift is actually accelerating up, right? So though you are going down, it is accelerating up. The acceleration of the block related to the inclined plane. So he's asking if you are inside the lift, then he's asking with respect to you. So it has mg, it has a pseudo force ma. So if you remember, if you resolve, so if there's an inclined plane, block mg is this way, if this angle is theta, the force component along the inclined plane is mg sine theta. The force component normally is mg cos theta. So you have to take the force component this way. So now we have two components. One is mg, other is ma. So we also have ma sine theta. So we have two forces in this direction. Agreed or not? Which is equal to mass into acceleration. Let this be capital A. Acceleration in this direction is capital A. So mass gets cancelled. So what is acceleration? Sine theta into A plus G. This is the net acceleration with respect to the inclined plane. Be clear, it is not with respect to ground. It is with respect to the inclined plane. G plus A sine theta. Next one. A uniform rope of mass m and length L is pulled along a frictionless inclined plane of angle theta. There is a frictionless inclined plane, angle theta. There is a chain. I have drawn it something like this. Total mass m, total length L. Force F parallel to the inclined plane. So I'm just converting the question into diagram. So to understand statement by statement, uniform, that means everywhere at the same mass per unit line. Okay. Tension in the chain at a distance x from the end at which force is applied. So I'm applying force F here. So x from here, he's asking what is the tension here. This is the question. I hope you understood this question. So I have converted the question into diagram. It's like a doctor, right? You have to read the problem case statement and draw the diagram. Imagine the situation. Now, you know one thing, there is a downward force, capital mg sine theta. Total mass is capital M. So weight is capital mg sine theta, right? So what is the acceleration? Acceleration is equal to F minus mg sine theta by M. So it is accelerating upward. So y is going upward. He gave F is greater than mg. If F is less than mg, it will go down. F greater than mg going up. F minus mg sine theta by total mass is acceleration. So total mass of the chain, right? Now the question is not that. He's asking the tension here. So the length of this is x. What is the length of the remaining one? L minus x. So I'm drawing the freeboard diagram of this one. I'm drawing the freeboard diagram of this. So here, the small one whose length is L minus x, or you can take the top one. If you want the top one, this will be x. So here will be force. And what is the weight of this? I'm taking the upper part. You can also try with the smaller one. I'm taking the part at the start. So mass is length is x. So what is the mass of it? Mass of it is length into mass per unit length. Mass per unit length is m by L. That is the mass of this. So mx by L into G into sine theta. That is the mass of this, right? So weight of this will be, is the mass into G sine theta. Acceleration is A. He's asking the tension. Sorry, here there's a tension T. So there's also a tension T. So this is one way of writing, or I can take this and write. So your wish. So if I write that F minus T minus mxg sine theta by L is equal to mass of this is mx by L into acceleration A. Now what is the acceleration? This one you have to substitute and solve it. So you'll get the tension. So F minus mxg sine theta by L. This A comes this side, so minus sine minus mx by L into acceleration is how much? F by m minus mg sine theta is equal to tension. T goes the right side, this comes to the left side. Is that clear, guys? So expand this, F minus mxg sine theta by L minus gets cancelled, xf by L minus into minus plus. Did I get one extra mxgl sine theta? Okay, plus we are getting m square. Huh? Did I miss any m? Minus t minus. How come I'm getting? Oh, this m won't be there. So there's a bracket here. So if I take that bracket off, this m won't be there. So plus mx by L into g sine theta, right, is equal to t. Clear? So we are getting these two cancel. So f into 1 minus x by L. Let me see, has anyone solved it? Anyone send the answer? Question number 9, option C. This is question number 9. You're getting option C. Did I miss anything, guys? As far as I have done, I guess, right? F minus, downward there is tension T, there is a weight of this component mx by Lg sine theta. This is mass into acceleration, and acceleration is F minus m. This is right. So I'm getting option B. Please do check again. I'll also cross check again. No issues. If you got it corrected, fine. Let me know. 10th one, two masses, capital M and small m. This is capital M, this is small m, are connected by arrangement shown in the figure. What is the downward acceleration of capital M? So downward acceleration. So this is also pulley system. You can assume this way. If you see, if this goes down, if this goes up 1 meter, so this length reduces by 1 meter, this length reduces by 1 meter. So total length of this reduces by 2 meters. So this will come down 2 meters. Do you agree? If it goes up 1, it will come down 2. Right? So if the velocity of this is v, the velocity of this will be 2v. The acceleration of this is a, acceleration of this will be 2a. I hope you understood this. This is called constant relation. Now, another logic, if the tension in this string is T, here it is T, here it is T. This is massless pulley. So if it is a massless pulley, this will be T dash, this is T, this is T. Mass of this will be 0. Acceleration is A. So T dash minus 2T is 0 into A. So this becomes 0. So T dash is 2T. T dash is how much, guys? 2T. The tension here will be, T dash will be 2T. So I can write this as 2T. Is that clear, guys? Hope this is clear for you. Now, I'll draw the freeboard diagram. He's asking what's the downward acceleration. He's asking what is A. So in the question, A is equal to question mark. Sorry, 2A. What is the downward acceleration of capital M? For us, it is 2A. So 2A is question mark. We have to find out 2A. So draw the freeboard diagram of capital M. So weight will be capital Mg. Upward tension is T. Acceleration is 2A. So capital Mg minus T is equal to capital M into 2A. Now small m. For small m, upward tension is 2T. Downward force is mg, upward acceleration is small a. I assume this as A, right? I got this as 2A. right? So as acceleration is upward, that means upward force is more. Here acceleration is downward, that means downward force is more. So for this, upward force 2t minus small mg is small ma. Now for acceleration, I have to eliminate tension. So what I will do, I multiply this by 2. So when I multiply this by 2, 2 capital mg minus 2t is 4 capital ma. 4 capital ma. If I add these two, equation, 2t gets cancelled. So if I take g common, 2 capital M minus small m is small m plus 4m into a. Am I right? So from this, I'll get acceleration A is equal to 2 capital M minus small m into g by m plus 4m. So for me to explain you, it might sound lengthy, but it's very easy to solve. Once you write, t, 2t and all, it is very easy for you to solve it down. Right? So we have 2 more questions. You can give it a try. I'll go to the other topics too. So once you get this, you can actually also take screenshots. Can you take screenshot of this? 10th and 11th screenshot, guys. You can try, give a, spring constant question. Once after the session, if I got time, I'll come back and solve this screenshot. Then this one. Right. So friction force, we have 2 frictions, static, kinetic. Till the body moves, till there is a relative motion, it is called static. Once there comes the relative motion, it is called kinetic. So friction F maximum is equal to mu times N. Mu is the maximum, means mu static. And once the slipping happens, F sliding friction, it is called sliding friction, mu K times N. This varies from 0 to mu naught. This is always fixed, which is mu. And most of the cases, maximum mu s is equal to mu k. If they are giving single mu, you will take this. If they are giving you separately, then yeah, you assume. So first question, I just gave it a little different. A body is taken very slowly. That means velocity is 0. Route 1 and route 2. That force is always tangent to the path. So when here it is F here, when here F dash is this way, and here F double dash is this way. So why I'm changing F dash, F double dash? Force is not constant. For every angle of inclination, force will change, right? That is why I took it this way. Quotient of friction is same for both the paths. So mu is same for both the paths. Work done. So he's asking, what is the work done? So work done is nothing but loss in potential energy plus work done against friction. So work per energy, right? Net work done is change in kinetic energy. So work done by friction plus work done by gravitational force, there are only 2 forces, is equal to delta Ke. Delta Ke is 0. This is work energy theorem. Okay. Generally, I'm telling you. So there is no change in kinetic energy. So if I take some random point on the loop, so I took a small length, this angle is theta. This theta is changing. Here it is 0, here it is increasing, then decreasing and all. Let the length of this be dl. Okay. So this should come in, I guess, the other thing, but anyway. So work done again. So now frictional force will be upwards, or the block is this way. Normal force N. Mg is this way. Normal is always normal to the surface. So this component will be mg cos theta. Oh, wonderful. So few of you have solved mg cos theta. Sorry. Yeah. And this direction mg sin theta. Right? So frictional force F is equal to mu times N. That is mu times mg cos theta. Now work done by friction. What is the work done by friction? The length along this direction is dl. So dw done by friction is fdl. So mu mg into dl into cos theta. This is a small work done by friction. So dw, small work done by friction is this. Now in this triangle, let me draw this. This is the triangle dl. The horizontal displacement is dx, vertical displacement is dy, and the length is dl. So this length, small length, I'm expanding it here. You understood? So I can write dx is equal to dl cos theta. Dx is equal to dl cos theta. Instead of dl cos theta, I will write dx. So mu mg into dx. So small work done is mu mg into dx. If I integrate, net work done is mg is constant, mu is constant. Integral dx is 0 to L. Integrate 0 from L. So mu mg L. We are getting mu mg L. And it is independent of the path. So it is same on both the routes. Is that clear? So though the route, it starts from this way or anything, it is same. It has to end at the same point. That is the logic here. Not this much, but yeah. So because if you turn it this way again and not this one, n becomes 0 in between, something like this. Next, 14th one. Find the minimum normal force to be applied by each hand to hold three identical position. The three identical books, mass m each. Each book has mass and value of quotient of friction between hand and book is new. So here friction is sufficient. Between the books, friction is sufficient to hold them. But between hand, suppose you are pushing it with 10, here also you should push with 10. So it is not equal. If n is more than n1 is more than n2, books will move to right or left. So n should be equal. This is n1, this is n2, n1 is equal to n2. So that books won't go left or right. So what is the maximum friction here? Mu times n, and friction here is mu times n. What is the total weight? 3mg. Total weight of this, weight of this, weight of this, 3mg. So net upward force is 2 times mu n is equal to 3mg. So n is equal to 3mg by 2. So 1 3mg by 2. Screenshot if needed. Easy question. Here friction is sufficient as he hadn't mentioned anything. No, so between the books there is enough friction. Two blocks A and B are separated by some distance and tied by a spring as shown in the figure. The force of friction acting on block at t is equal to 2 seconds is. So he's asking at 2 is equal to 2 seconds. So f dash is 2t. It is not constant. F dash is 2t. This is 4. Now what is happening? Okay, this is lengthy. I would ask you to take screenshot. We'll solve it at the end. Right? So what is happening at initially 2t is 0. And what is the frictional force here? Okay, let us solve then. This is 1 kg. This is 2 kg. This is f dash, which is 2t. This is f, which is 5t. Right? This is 1, this is 2 kg. Now, at initially, this is 5 Newton, right? 5 Newton. What is the F maximum here? F maximum is U times N. 0.5 times n is how much? Normal force. What is the normal force here, guys? mg. Mg is how much? Mass is 1, g is 10. 5 newtons. F max here, F1 max. The maximum friction force here is for B block is 5 newton. And what about this F max? F max is equal to 2 into 10 into 0.6. 2 mg. Mass is 2, no? So friction is 0.6. So 12 newton. How much is it? 12 Newton. Now, at t is equal to 2 seconds, at 2 is equal to 2 seconds, what is the F dash value? So F dash at 2 seconds is equal to 4 Newton. Now, when I'm applying 4 Newton, will this block move, guys? It is to see here we have 5 Newton, 5 Newton. It will take care of itself, right? So here at B block, the friction here is sufficient to cancel this. But here also, it is much more. This is 4, this is 12. So how much will be there? 4 only. So it won't act 12. 12 is the maximum. Suppose what I mean, you got a pocket money of 100 rupees. If the chocolate costs you pocket money of 12 rupees, chocolate is 4 rupees. So you'll pay 4 rupees only, right? So here the friction will be 4 Newton. And here, this is 5 rupees. You have only 5 rupees. So you'll apply opposite 5 rupees. So left side it is 4 Newton, right side it is 5 Newton. I hope you understood this. Let me see how people approach this. 10th question, option B. Okay, sir, option A. Okay. 10th, yes. Okay, good. Now, 16th one. Blocks A and B of mass 5 kg and 10 kg respectively are placed on a smooth inclined plane of inclination 30 as shown. Oh, I guess block A and B is subject to 5 newtons. This diagram is missing. So let's leave it for now. Diagram is missing. Then 17th. In given figure, quotient of friction between incline and block of mass m is mu is ax. So mu here is not constant. Mu is equal to a into x. Where a is positive constant, the block is given initial velocity v naught, x is 0. This is a point, x is 0. You have given initial velocity. The condition for the box to remain at rest once it comes to rest. So once it stops, it should stop in between the top and the bottom somewhere. Okay, the x is a distance of the inclined plane from the bottom. So it is a little lengthy question, guys, but still you guys can do. Mu is not constant. It comes under friction, as well as these are the little intelligent questions, as I mentioned. It will take some time, but you people should be able to solve it. Little difficult ones. So this is mass m, velocity v. The frictional force is mu times n. So n, what is the n? Draw the free body diagram. M. So mg is this way. N is here. So mg component, mg sine theta, mg cos theta, and frictional force. So what is the frictional force in this, guys? N is equal to mg cos theta. So friction is equal to mu times n, right? So mu is how much? Ax times n is equal to. So friction is not constant. It is changing as a function of x. So if you see the acceleration, it will actually accelerate backwards or retard. So net downward force is mg sine theta plus ax mg cos theta is equal to mass into acceleration. Clear? I hope you understood. So first is work energy theorem. What is work energy theorem? Total kinetic energy of this should go into work done against friction and work done against gravitational force. So either you can take this as a force, net force, right? So you can integrate. So change net work done is changing kinetic energy. Integral f dx is delta k. So delta k, final kinetic energy is 0. Initial kinetic energy is half mv naught square, right? Now displacement is upward, force is downward, so we have to keep minus sign. So it is minus integral f dx. So minus minus gets cancelled. Substitute this force there. So I don't have much space there. I'll write somewhere down here, guys. Please understand. Yeah. So integral mg into sine theta plus ax cos theta into dx. Okay, is equal to half m v naught square. He didn't give any length. Where x, where is the cost? Right. So integrate 0 to L, assume some length L. Okay. But he's asking L, he's asking velocity. So once it comes to rest, it should be at rest. I'm getting L here. So mg into sine theta into L plus a cos theta into L square by 2 is half mv naught square. It is not asking length L, no, it's asking velocity v. And when is at rest? At rest means the frictional force, as when it comes to stop, theta is given as alpha, so change that. So mg sine theta should be equated by frictional force. F is equal to how much? Mg, F is equal to mu times n. Now, if the length is L, frictional quotient will be AL into mg cos theta. This is the condition. So when it is coming to rest, mg sine theta is equal to mu is nothing but AL into mg into cos theta. Mg gets cancelled. So L is nothing but sine theta by cos theta by AL. Substitute this L here and you can solve it. So somewhere here L we have tan theta, no? Tan square theta. So by tan theta. Sine by tan, this will be cos. It's asking V square now. So numerator may cos, and here L square, sorry, sin square by cos square. 1 cos sin square by cos. Where is that sum? M gets cancelled. 2 comes here. 2g sin alpha. Right? Yeah. So L sin theta and sin square by cos theta. Now just you have to simplify once. G sin theta. 2 gets cancelled here. Plus A cos theta into, here L is sin theta by AL. Oh, another L I mean, okay. Yeah. Plus A cos theta into sin square theta by cos square theta into A square. How come I'm missing something? Cos square theta into sin theta. Let me check. I have to simplify this. Yes. I will cross check this. So somewhere we might have missed sin or cos. I'll solve and resend. So at the end we'll come back to this question. So maybe we missed some sin theta or cos theta. Have anyone solved? Let me check. Not understood. Okay. So we'll get back to this question later, guys. No issue. So you can keep it. Simplification, somewhere we might have done mistake. Okay. Next one. A body with zero initial velocity slips from the top of an inclined plane, forming an angle alpha with the horizontal. Again, the same type. The coefficient of friction mu between the body and the plane increases with the distance s. After what distance the body will stop? So this is the answer. Already we solved it. L is equal to tan theta by A. G also gets cancelled. L is equal to tan theta by A. Do you have that? Yeah. So instead of capital A, we have this small b, right? Instead of theta, we have alpha. So at the highest point, if it has to come to rest, at the highest point it has to come to rest, then same thing. AL mg cos theta is equal to mg sin theta. So we already solved it. It's like you have given, there is a rough surface, guys. You have kicked the block with velocity v0. The block slows down and comes to rest at some point. That is the highest point. So at highest point, friction will cancel mg sin theta, mg sin theta. So downward force is mg sin theta, upward force is mu times n. Mu times n is equal to how much? Mg cos theta, and mu has given us ax. Ax mg cos. That's 19th. 20th. This is work energy, work per energy. So net work done, W net is equal to change in kinetic energy. Power is equal to rate of work done, right? Or rate of change of kinetic energy, in short. A body moves from point A to point B under the action of a force varying in the magnitude as shown in the figure. Find the total work done by the force. So small work done is F dot ds. This is dot product. Now we have to integrate. So net work done is integral F dot ds, or area under the graph. So what is the area of the triangle? Half, base is 5, height is 10, right? Plus area of this 7 minus 5, 2 into 10. This is 25 plus 20, 45 joules. See the units, meters, newtons. What is centimeters? It is your job to convert it. So easy question. Work done is area under the graph. Next one, a body is constrained to move along z-axis of coordinates system is given being applied by a force constant F. So there is a constant force. F is 2A plus 3J plus 4K. Find the work done. Find the work done by the force in moving the body over a distance of 5 meters along the z-axis. Right? Okay. So there is z-axis, 5 meters. X component, Y component, delta X is 0, delta Y is 0. There is no change in XY components. So we only need to take the force along the Y direction because displacement in the X and Y direction is 0. We have only need to take a force in the Z direction. So force is constant is force. So work done is equal to 5 into 4, 20 joules. So or we can write this is 0 I cap plus 0 J cap plus 5 K cap. And do the dot product with the force. So it is F dot S, no, F is 2I plus 3J plus 4K. And do the dot product, these two become 0, 5 4s are 20. Take this screenshot. If it's very easy questions, basic questions. A body is acted upon by a force which is inversely proportional to the distance covered. So force is inversely proportional to the distance covered, 1 by S. The work done will be proportional to, so again, work done, small work is F dot ds, integrate karo. So work done is 1 by S ds. So instead of force, I can write K, some constant by S. So K by S. K comes out, it is ln S. Ln S, which is not there, so none of the above. So what I am trying to do, even our IIT mains paper, we have more than half as easy questions. If you are really good at your NCERT textbook, you understood the concept, understood the questions given at the end, you're able to solve it on your own, right? And if you are okay with the previous mains question, not all, at least 50%, you can solve the 50% mains paper. The paper is designed such a way to eliminate people, not select. They just eliminate. How? They will tempt you in making mistakes. You feel as if like I know everything and you commit mistake, or you spend over time on a question. Like some questions, they kind of pull you in. You just get stuck up there. You enjoy solving that question. You won't get done. It's like a puzzle. So you enjoy, time is up, done. So you lost it. So please be clear. Half or more than half is actually easy. 30% like that is moderate. Last 20% is difficult, which decides like top 100 or top 200 rank or top 1000. So if you're aiming for that, you have to do all three. If you're just aiming for less than that, I mean, little greater rank than that, like 10K, something like that, moderate, and around 10K, 5K, 10K, easy ones, just by doing half of the paper, you'll get less than 10K rank. I can assure you that. So don't aim for the difficult ones. Leave the difficult ones. That's how you save time instead of stuck in the question. Like I wanted to complete the session with more number of questions. So I have left that question, right? So though we weren't getting, I didn't go and, kept solving that and all. So we have to give that break. Okay, now yeah, take it. Let's stop there and go for the next one. At the end, if you got time now, go back and solve. Still got time, then do it. Wonderful. Next, a 12 kg block moving on a frictionless surface with a velocity of 4 compresses an ideal spring and comes to rest. So there's a spring, ideal spring. There is a 4 kg block, 16 kg block moving with a speed of 4 meters per second. Force constant K of this is how much? 100 Newton per meter. Then how much in the spring compressed? So when the block hits it, it compresses it. When the block comes to rest, right, then how much is the spring compressed? So when the block comes somewhere here, so block comes to rest somewhere here. So velocity is how much? 0. And the compression in this is x naught, not this, the compression. This is x naught. The compression is x naught. So half mv square, the energy lost is equal to energy in the spring, half kx square, spring potential energy. So 2 gets cancelled, mass is 16, v square 4 square, is k is 100 into x square. So x is equal to under root 16 is 4 square into 4 square by 100. No need to multiply. This is what you have to see. 100 is 10 square. So 4 into 4 by 10. How much? 16 by 10, 1.6 meters. So if you kept on multiplying 16 16s are 164 by 100, divide. Don't do that. Bring it to the end and solve it. Sorry, 256, sorry. Right? Yeah. A block of mass m is equal to 2 kg is attached to the two unstretched, it is not unscratched, unstretched springs of constant K1 is equal to 100 and K2 is 125. The block is displaced towards the left through a distance of 10 centimeters, left towards 10 centimeters. That means this is under compression and this one is under stretch. Okay. So it is under stretch, it is under compression. Please be clear because both are attached. If they are unstretched springs, right? If it is not attached, then this won't get stretched. So if there is attachment here, it gets stretched, it gets compressed. If there is no attachment here, still there will be compression on the left spring, but there is no expansion or stretching in the right spring, elongation in the right spring. Find the speed of the block as it comes to the mean position. This is the mean position. So energy stored half, K is how much? 100. X is how much? 10 centimeter. That means 1 meter, 0.1 square. Plus energy stored in this half into 125 into again 0.1 square. If it is going 10 here, this is also getting elongated 10 here. No. So both you have to consider is equal to half. Mass is 2 into V square. 2 gets cancelled. Solve for it. So velocity. So it is 1 plus 1.25 under root 2.25. Am I right? What is under root 2.25? Is it 0.25? 100, 1 by 100, 100. 1.25 only, right? Another 2 is there, sorry. Another 2 is here. Another 2. So divided by 2. Under root 1.12. So 11, 1.02. Am I right? Or 2s are 4, or 4 4s are 16. So is it somewhere it went wrong, guys? What happened with this? No, how come this came? Yeah. I guess then 4 4s are 16 should be something like this, no? See. Let's square it. So 1.04 is 1.16. That is near to this. Next one, a spring placed horizontally on rough surface is compressed by a block of mass m placed on the same surface so as to store maximum energy in the spring. The coefficient of friction between the block and the surface is mu, the potential energy stored in the spring. Good question. Spring placed horizontally. There is a spring placed horizontally. It's compressed by a block of mass m. There is a block of mass m on the same surface so as to store maximum energy in the spring. If you are applying force F, spring gets compressed. But what happens here, as the air pushing, the compression happens, the spring force Kx keep on increasing. So when it is at level where it reaches F maximum is how much? Mu times N, which is mu times mg. So when this Kx is equal to mu mg, the block will start slipping. That is the maximum compression you can give. So x naught is equal to mu mg by k. So the maximum potential energy is half k x square x naught square. So it is half k into mu square m square g square by k square. So mu square m square g square by 2k. So mu square m square and 1k, right? Should be 1k. Yeah, mu square m square g square or g. Mu square m square g square by 2k. Right? Not C, A. C there is single g and on A it is g square, I guess. Yeah. So 1k gets cancelled. That's it. Next, if a constant force F is equal to 3i, again the dot product, find the network done. So dot product F bar dot R bar 3i plus 4j plus 5k dot 3i plus 4j plus 6k. So dot product 9 plus 16 plus 30, right? 25, 55, 55 joules. A projectile is projected with initial velocity 20 meters per second and an angle of 30 degrees from the horizontal. Find the total work done when it hits the ground. So mg is always downwards, and the net displacement when it is starting to ending, net displacement is how much, guys? 0. Net displacement is how much? 0. So net work done is 0. A particle of mass 1 kg is moving along x-axis and the force F is also acting along x-axis. Along x-axis. Force is also acting along x-axis such a way that its displacement is varying. He said x is given as 3t square. Find the work done by the force F when it moves to 2 meters. So when change in displacement is 2 meters, what is the work done? So either you can say work done is changing kinetic energy, or we can say work done is integral F dot ds, or in this case F dot dx. From this, what is velocity? Dx by dt, velocity is equal to 60. Differential of t square is 2t. Acceleration, dv by dt is equal to how much? 6. So work done is F dot s, force is constant. Work done is F dot s, force is constant. Mass is how much? 1. Acceleration is 6. X is equal to 2. 12 joules. It is 12 joules. And we got just 3 more questions. 30th is little interesting. Just let me see how you people are doing there and come back. Any questions? 1.04, right, Shaga? Yeah. So other two, you just 31 take screenshot once. If you again get, there's a time delay, right? So in the meantime, you can solve it. And 29th. Yeah. So 30th one, a particle of mass m is moving in a circular path. There is a circle. It is little relevant to circular path. Radius r. Centripetal acceleration AC is varying with time. AC is equal to k square r t square. Centripetal acceleration is v square by r, if you remember, right? Where k is a constant. What is the power delivered to the particle by the forces acting on it? So we should have two forces. We'll see that. So v square is equal to k square r square t square. So v is equal to krt. Acceleration is equal to k times r. This is tangential acceleration. This is centripetal acceleration. This is centripetal acceleration. This is tangential acceleration. There is a tangential force of tangential, which is mass into tangential acceleration. Displacement is only this way. Displacement is only this way, right? If the velocity is v. Now, when you ask power, power is F dot v, right? Power is what? F dot v. Now, due to centripetal acceleration, there is a centripetal force Fc. But this is velocity is tangential. So power due to centripetal force is 0 because it is normal to the velocity. So here we should do F tangential dot V tangential, which is dot means cos 0, 1. So F tangential is how much? Mass into acceleration, mass. And what is acceleration? K into R. Now what is velocity? Power delivered to the particle by the forces acting on it. Instantaneous power is m k square r square t. This is instantaneous power. Straight. They miss any mass. K square t square. Acceleration here, which is v square by r. K square is krt. Acceleration I have differentiated tangential k into r. Right. Then tangential velocity is krt. power is this only, right? F tangential dot velocity. Yeah. Power delivered. This is the instantaneous power which is getting delivered to it. Cross check this. Why there is change in this, or does he mean anything else? You have to check. They ask you change in kinetic energy, half m into k square r square t square. Even that is not there. Mass k RT. Okay. Next one. Power applied to a particle varies with time as power is given. Find the change in kinetic energy. So work done. dW by dt is power. So delta W is integral p dt, which is change in kinetic energy. So integrate 40 cube minus 5t plus 2 into dt. Integrate this 4t power for 4 minus 5t square by 2 plus 2t. Right? Substitute this. T varies from 2 to 4. So 4 power 4 minus 2 power 4 minus 5 by 2 into 4 square minus 2 square plus 2 into 4 minus 2. Right? Simplify this, you'll get the answer. So let us see. So this one, 30th, and there's another question, I guess. Yeah, this one. So I'll be sending you again in the next session or something. I'll try to give the solution again. Right? So you can take it down or take the screenshot of it. Just a second. Okay, 31 you got. See how to get PDF. Do we have any WhatsApp group? Right. So we don't have any WhatsApp group. I just checked with the ma'am. So what ma'am said, they'll be sharing you the documents as well as the links of the previous video sessions with you during the class session, maybe next session or sometime. So they will share the links. So you can download from there. The classes, yeah, we are giving that as PDFs only to them. They'll be forwarding it to you through some channel or during the session, they will post the link. Okay, PDF links. So I cannot share here. So that is a problem. So I cannot share. Right? Any more questions, guys? Can ask any questions as such. As I again mentioned, please go through the previous questions, previous IIT mains. So you can buy this in the market, last 35 years, last 40 years, textbooks like Arhan series or whatever. So thank you, Usha. Thank you for that. So please go through those questions, solve it, try to understand, see the solution. So there's one, if you can send a screenshot here, that would be great. I don't think you can send any screenshot, I guess. Okay. So please be free, guys. Feel free, whatever questions you got, post it. So let us meet in next session, right? You'll be having, there's a small change. Tomorrow it will be chemistry. Day after tomorrow it will be maths. Thank you, Kirtana. Thank you, Nishant, Varsha, Sriram, Nishant, everyone. Happy Pongal. Happy advance Bogi, advance Pongal. Bye. Thank you, guys.